Okay. All right. So we correct it. So actually it should have been x cubed plus 2x minus 4 equals 0. So my derivative is going to be 3x squared plus 2. And the initial guess is that the value of this is 1. So I follow the method then. X of 2 is then going to be my first guess, which is 1, minus 1 cubed, 2 times 1, minus 4, over 3 times 1 squared, plus 2. Right? So if I look at this, let's see, that's going to be 1 plus 2, which is 3, minus 4. This will be a minus 1 on top. And then at the bottom will be 3 plus 2, which is going to be 5 on the bottom. And so 1 minus a minus 1/5 is going to give us 1.2. So that's my second approximation. And so now we do the same process again. And so x of 3 is going to be 1.2 minus 1.2 cubed, 2 times 1.2, minus 4, over 3 times 1.2 squared plus 2. And that'll give us our second approximation. Our third answer. Right? And so we would then plug that into a calculator, and that would give us a new answer. And then we could just barely keep this process going and going and going as far as we want to go in terms of how good do we want our answer to be. Okay? So in terms of the questions you'll have in the book for work, is they'll tell you how far they want you to go. Right? So I'll leave this calculation for you to get that x number, and then you can try to get x of 4. Okay? So the last section for today, section 4.9, you start getting into the other branch of calculus, which are called anti-derivatives. Right? So for example, if my derivative was 2x, and I want to know, well, what was f of x? So what was the original that gave me that derivative? Well, there are some possibilities. It could have been f of x was x squared, because that would give me that derivative. It could have been f of x was x squared minus 2, 9, 8, 7, 6, 5, 4, because that also would give me a derivative of 2x. Or it could be that f of x was x squared plus 3, 9, 8, 2, 7, 5.432, right? All of those are possible. And it was more and more than that, right? So it could have been any of those, right? So in terms of doing the antiderivative then, we get this. So let's say we want to find the antiderivative of something in this form, ax to the n, right? Well, basically we're going to do the opposite of what we did when we did derivatives. So now the process is this is going to be ax to the n plus 1, and now we divide by n plus 1. Right? So, for example, the antiderivative of 5x cubed. Right? So this will be 5x to the 4th over 4. So we add 1 now to the x1 and then divide by that same number. Right? So now we got where we're starting with the derivative, and we want to know what was the original function. So for example, if I tell you the derivative was 12x squared plus 6x minus 4. And we want to know what is the original. Well, the original now will be 12x cubed over 3, 6x squared over 2. And now when we do the antiderivative here and we got a constant, now we introduce the variable. And because there could be whatever number at the end, we add that c, which stands for some constant. And so this could be simplified to 4x cubed plus 3x squared minus 4x plus c. Right? So now, just like before we had derivatives, and if I gave you a point xy, we could actually get the slope. Now, if I have a point, I could actually know the exact equation because I could solve this and get c. So let's say, for our example then, that the point 110 is on the curve. So that means I'm now going to take those numbers and plug in. And so we're going to get that 10 equals 4 times 1 cubed, 3 times 1 squared, minus 4 times 1 plus c. So 10. So this is going to be 4 plus 3 minus 4 plus c. So 10 equals 3 plus c. And so c will equal 7. And so my exact equation then would be 4x cubed, 3x squared minus 4x plus 7. Right? And that would be the exact equation. And we could find that because we were given a point on the curve. Right? So again, let's go through another example. So let's say we want to find f of x, and this time we're given the second derivative, which was 6x plus 12x squared. So my first derivative, so now we're working our way back, is going to be 6x squared over 2, 12x cubed over 3 plus c, right? Because again, we don't know what that number was up there. So this becomes 3x squared, 4x cubed plus c, right? Right? That's the first derivative. And then we get to the original by doing the antiderivative again. And now we get 3x cubed over 3, 4x to the 4th over 4, cx plus d. And we can simplify this, and we end up with x cubed, x to the 4th, cx plus d. And that would be the original. And again, if we knew some information, we could find out what c and d are. Right? Other ones. Okay? So you had that handout I gave you a few weeks ago that had the differentiation rules on top, and then it had integration rules on the bottom. And so you have one like this. And we want to find f of t. So from that handout, you'll find out that the antiderivative of e to the t is e to the t. And for sine, you get negative cosine. Right? So we end up with something like that. Right? Other ones, is, let's say I get something like this. X squared plus 4x plus 8 to the 5th times 2x plus 4. Well, I'm going to do this one, and we want to do this, and we're going to make use of that basic rule I had earlier, that ax to the n, and how I can integrate that. And so we're going to do a little substitution here. I'm going to say u is going to be x squared plus 4x plus 8. The derivative of that is 2x plus 4. So now we get, this will be u to the 5th du. And so we can integrate this, antiderivative this. Right? So we integrate antiderivative of u to the 5th, we get u to the 6 over 6 plus c. And then the last step would be the substitute, x squared plus 4x plus 8 all over 6 plus c. And we'll be done. And that will conclude this lesson.